Welcome to a Greenway Engineering Environmental Laboratory tutorial. This tutorial will instruct you how to properly prepare a standard home faucet, also referred to as a sample tap, for collection of a coliform bacteria sample for laboratory analysis. The first step is to determine if you will sample with or without shock disinfection of your well and/or plumbing system. Circumstances that warrant shock disinfection prior to sampling are having a newly drilled well or installing new sections of plumbing, maintenance or repair of the well or plumbing at your home, such as well pump replacements, pressure tank replacements, or the installation of other new potable water well equipment. Stagnant water must be flushed away, and in most cases, both the well and plumbing system will need to be shock disinfected prior to collecting a coliform bacteria sample if a home has been sitting unused or vacant. It is recommended to wait at least 7 to 10 days after shock disinfection to collect a coliform bacteria sample. During the 7 to 10 days of waiting, there should be regular water usage in the plumbing system. This period of regular water usage allows the well to reestablish itself to normal conditions. Should you decide to collect your coliform bacteria sample immediately after shock disinfection, please note that a false negative sample could be obtained. The second step is to determine if you will sample with or without any home water filtration or treatment systems in place. In most circumstances, when refinancing, purchasing, or selling a home, the lender or mortgage company will want to see the quality of the groundwater in the potable water well without any home treatment devices in place. It is always recommended that you check with your specific lender, mortgage company, regulatory agency, or other authority prior to collection of your samples so that you are aware of any specific sampling requirements around your sampling situation. Should you decide to sample without water treatment devices such as whole house filters, water softeners, or other types of filtrations or treatment in place, check with the manufacturer of your specific treatment devices to properly bypass them before collection. The third step after determining whether you will sample with or without water filtration or treatment devices in place is selecting the best faucet or tap for you to use for collection of your coliform bacteria sample. There are several types of sample taps that you should not use to collect your sample. Faucets where the aerator cannot be removed should be avoided. These types of devices can harbor bacteria and prevent thorough disinfection. Swivel-type faucets should also be avoided. This means most kitchen taps should not be sampled from, as a kitchen tap almost always has a swing or swivel-type connection. Mixing-type faucets should also be avoided, as they mix the hot and cold water together through the same plumbing line. If a mixing-type faucet is your only option, close the hot water supply valve at the bottom of the sink prior to collecting your sample. Furthermore, you should never sample for coliform bacteria from a faucet that leaks. Faucets that are rarely or never used should be avoided as well, since stagnant or unused water can grow bacteria as it sits in a pipe or fixture. It is also never recommended to sample from an outdoor tap, such as a frost-free yard hydrant. They are often threaded, meaning a hose can be connected to the fixture, which allows for a greater chance of contamination and makes it more difficult to fully disinfect all the surfaces. However, there are certain situations where a pressure tank valve or outdoor hose bib may be your only option to sample from. If you believe a pressure tank valve or an outdoor hose bib is your best choice for collecting your sample, please contact our laboratory so our trained staff members can walk you through better options that you might have or instruct you how to properly collect from the pressure tank valve or hose bib, as the collection process is different than we described in this video tutorial. Next, check that your sample kit has everything in it to properly obtain your sample. There should be a set of printed instructions, nitrile gloves, at least 2 sample containers, a chain of custody form, and several plastic bags. If you purchased a testing kit to sample a shocked well, DPD total chlorine reagent powder pillows will also be included in addition to a third sample container with a 10 milliliter calibrated mark to test for chlorine. Now that you've finally found the right faucet to sample from, you've bypassed any water treatment devices necessary, and you've confirmed that everything you need is within the kit that you've been given, it is now time to sample. The first step is to remove the aerator. This is extremely important because aerators can harbor bacteria which can affect your sample. Some of them simply twist or spin off, while others may need a specialized tool to remove them. It is critical that the aerator be removed prior to flushing and disinfection, or your sample may fail for the presence of total coliform bacteria, as aerators can harbor bacteria. Once you have removed any aerators, strainers, hoses, attachments, or treatment devices, you are now ready to flush the cold water only for a minimum of 10 minutes. The longer you can allow the cold water to flush at the tap where the sample will be collected, the better the chance of the tap to be cleaned of any bacteriological buildup that can contaminate a coliform bacteria sample. Use your best judgment regarding your well and septic system as to how long you can flush your cold water tap prior to sample collection. After you have flushed the cold water only for a minimum of 10 minutes at your most ideal sample tap, with all aerators, washers, or other attachments removed, it's time to check for the presence of chlorine, only if you have shock disinfected your well. If you have not shock disinfected your well, you do not need to check for the presence of chlorine, and you can skip to the next step. To check for the presence of chlorine in your well, ensure the cold water has been running, and then fill your container designated for chlorine checks with water to the 10 milliliter mark. Add the contents of 1 silver pouch, also referred to as a powder pillow, of total chlorine DPD to the 10 milliliters of water in the designated container. Swirl to mix for 20 seconds, and then allow the sample to sit 3 to 6 minutes on a white background or surface, like a plain piece of white paper. After 3 to 6 minutes, evaluate the color of the water in the container. The darker the pink color, the more chlorine that is still present in your well water, and the longer it will take to flush away. You will see the pink color gradually fading away as you flush the water lines. You are not ready to disinfect and collect your sample until there are absolutely no traces whatsoever of pink color after adding the contents of 1 total residual chlorine DPD powder pillow to 10 milliliters of well-flushed well water. The total residual chlorine DPD chemical should not be evaluated after 6 minutes of chemical reaction. It will turn pink after 6 minutes, and that does not indicate that chlorine is present. Do not consider a sample that has turned pink after 6 minutes to be present for chlorine. Should the reverse situation occur, meaning that the sample goes from dark pink to immediately clear within a minute, that indicates that the chlorine level is too high to be checked using total residual chlorine DPD indicators. Perform a dilution on the sample, or use a chlorine testing method that reads in a higher range to determine how much chlorine is in the well water currently. If you did not shock disinfect your well, you can begin to disinfect the inside and the outside of your sample tap after flushing the cold water only for a minimum of 10 minutes. If you did shock disinfect your well, you can begin disinfecting your sample tap after you have flushed the cold water and ensured that no chlorine is left in your well system based on what the chlorine DPD powder pillows tell you about the presence of chlorine in your well water. Use a cotton ball or pad saturated with household rubbing alcohol to swab and disinfect both inside and outside of the tap or fixture you intend to sample from. This will ensure a thorough disinfection. We recommend cotton balls or cotton pads over Q-tips or alcohol wipes. Do not use Clorox wipes, Lysol wipes, or any other type of disinfectant other than standard household rubbing alcohol. If your cotton balls or pads are showing dirt, rust, or discoloration, continue to swab and disinfect with new cotton balls saturated with isopropyl alcohol until the swabs are clean. Allow a minute or so for the alcohol to disinfect any bacteria on the surface of the sample tap, and then turn the cold water on to a moderate flow. Allow the cold water to run another 5 minutes after the disinfection process to flush away all the disinfectant prior to collecting the water sample into the sampling container. At this time, after your tap has been flushed and disinfected, you should put on a new clean pair of nitrile gloves as provided in your sampling kit, and open your sterile sampling bottle. The water should flow in a laminar manner. It should not roll off the exterior of the faucet into the sample bottle, but rather straight downward out of the tap and into the sample bottle. Fill the container past the 100 milliliter mark, but leave at least 1 inch headspace at the top of the container. Next, fill out the QC check sample container and any additional sampling containers provided in your kit. As you fill any additional containers provided in your kit, be sure to leave at least 1 inch headspace in those containers as well. If not already completed, complete the information on the label on the sampling container so that your sample can be properly identified on receipt and throughout handling in the laboratory. Place your sample bottles into the plastic bags provided, and then place the bag containing the sampling containers into a cooler with ice. It is suggested, but not required, to chill coliform bacteria samples after collection until receipt in the laboratory. Coliform bacteria samples can be chilled using wet or blue ice, as the suggested temperature requirement is less than 10 degrees Celsius. If you sampled for anything other than total coliform and E. coli, it is recommended to use wet ice to chill the samples to less than 6 degrees Celsius. Blue ice is insufficient when chilling to less than 6 degrees Celsius is required. Only use blue ice if you are sampling only for total coliform and E. coli and wish to thermally preserve your sample during storage and transportation to the laboratory. Please ensure that your chain of custody form is filled out in its entirety and delivered with your sample to the laboratory. Our laboratory is located at 151 Windy Hill Lane in Winchester, Virginia. There is a doorbell to ring when you arrive at the laboratory. Please ring the doorbell on arrival and do not enter the laboratory. Only laboratory staff members are to enter the laboratory. After you ring the doorbell, a laboratory staff member will greet you outside to accept your samples and chain of custody form. Our staff member will ensure your chain of custody form is complete and accurate, and then you will relinquish your samples to the laboratory by signing your name on the relinquished by line and then putting the current date and time of sample delivery to the laboratory on the line next to it. The laboratory staff member will also verify that your sample was delivered on ice and note whether it was wet ice or blue ice, as it is required of us to document the type of ice the samples were transported on, if any. Please do not hesitate to contact our laboratory should you have any questions or concerns whatsoever. We are thrilled to be able to assist you, and we thank you for choosing Greenway Engineering Environmental Laboratory for all of your analytical laboratory needs. We are looking forward to exceeding your highest expectations.